Tonight's hot topic is analyzing the graph of the first derivative. So this is an extremely common question on our AP exam, and I think you'll see it several times throughout the exam. So we've got a lot of time to practice, but I don't think it's too difficult. It says the figure below shows the graph of f prime. Alright, so I need you to neatly sketch this in your notebook, and we're going to use this graph quite a bit. Notice our roots are -7, 0, and 6. And here's the big deal. They're telling you, and this is huge, that this is f prime. I think you're crazy if you don't put a huge f prime next to it. Alright, sometimes they give you f, sometimes they give you f prime, sometimes they give you f double prime. Make sure you know who you're talking about. So it says f prime, the derivative of f, is on the closed interval -8 to 7. So they're telling you we're ending at -8 and we're going to 7 here. The graph of f prime has horizontal tangents at -3 and at 4. So I'm going to go to -3, and I'm going to put my horizontal tangent, and I'm going to go to 4 and put a horizontal tangent. Okay, so they're telling me horizontal tangent means I have slopes of 0. The function f is twice differentiable, so you can take the derivative twice. And they give you this something here called an initial condition, which we'll deal with later on. So here is my suggestion. The questions are always about f. Alright? And we've talked about f prime and f double prime. What we're going to do is we're going to go make two sign charts. Our first one is going to be about f prime, and our second one will be about f double prime. So let's start on our first one. F prime, describing f. I know my function ends at -8. So it's the closed interval from -8 to 7. Now here's the whole trick. Okay? You have f prime. You are making a sign chart about f prime. Every time you make a sign chart, you ask yourself, when does the derivative equal 0 or does not exist? Okay, you are asking yourself these same two questions every single time. That's all we've done for a good, 4 weeks now. When does the derivative equal 0? So you say, well, this is a graph of the derivative and it's equal to 0 here, here, and here. Therefore, those are your critical points. Okay, you are not looking at the slopes. You are literally looking when this derivative equals 0. So my critical points are -7, 0, and 6. Now, I'm looking at f prime. And between -8 and -7, what do you know about the values of f prime? Well, since this is a graph of f prime, and if I look between -8 and -7, the graph is below the x-axis, which means it has negative values. Therefore, my function is decreasing. Between -7 and 0, the function f prime is above the x-axis, therefore it has positive values, which tells me my function is increasing. Between 0 and 6, my function is below the x-axis, so I have negative values, which tell me I'm decreasing. And between 6 and 7, my function is above, so I have positive values, and my function is increasing. Now remember, this is describing what the function's doing. This is describing the derivative. Now, we always said we're going to deal with f prime and f double prime, so let's make a sign chart for f double prime and take a look at the difference. Okay, so I'm going from -8 to 7 again. Now here's what I'm saying this time. I have f prime. I want f double prime. How do I go from f prime to f double prime? Hopefully you're saying, take the derivative. Okay, so let's make a note next to the sign chart. Take the derivative. Now, another word for derivative, of course, means look at the slope. Now, I'm literally going to look at the slopes. Starting at -8, all of these slopes are positive. Draw little tangent lines on there if you can't tell. I'm positive till I get to right at my horizontal tangent, which they told me was -3. Then all of my slopes are negative till I get to my horizontal tangent, which was at 4. Then all of these slopes are positive. Now the second derivative, remember, is describing concavity. So I've got concave up, concave down, concave up. If you make these two quick sign charts, you should be able to answer a whole ton of questions about the function. So now that we've got our sign charts, let's answer some questions. Letter A. Find the x-coordinate of each local minimum of the graph and justify your answer. Alright, so here's the calculus term popping out of the page. I want a minimum. When I find maxes and mins increasing and decreasing, I am looking, so that's telling me take the derivative. And who do they want it of? F. The derivative of f means look at f prime. So all I'm going to do is I'm going to go to the sign chart of f prime that I made and see when I have a min. Well, this went from decreasing to increasing. That just made a min. Increasing to decreasing. That made a max. Decreasing to increasing. That made a min. So I would say I have a min at x equals -7 and x equals 6. And my justification needs to be about calculus. So f prime changed from negative to positive. Notice I'm describing the derivative part. And it's that simple. The sign chart tells you everything. All right, let's attack another question. Part B. Find the x-coordinate of each point of inflection of the graph of f. All right, so let's slow down. Point of inflection is your calc term. When I see point of inflection, I'm looking for f double prime. So all I'm going to do is I'm going to go to my f double prime sign chart. That's why I created this. A point of inflection, let's start with the justification. I have a point of inflection when f double prime changes signs. Okay, so if I look at my sign chart, f double prime went from positive to negative, therefore -3 is a point of inflection. Negative to positive, therefore 4 is a point of inflection. So I would say f double prime changes sign, so I have a POI at x equals -3 and x equals 4. And we're done. Okay, so use those sign charts. Let's try another one. C. Find all intervals on the graph where f is concave up and has a negative slope. Okay, so when I see concave up, I'm saying f double prime. And if I'm concave up, I know f double prime is positive or greater than 0. And when I see the word slope, I'm thinking f prime. And if f prime is negative, it needs to be less than 0. So I basically have to look at my two sign charts and compare. I need f double prime to be positive, but I need f prime to be negative. So it's similar to that slowing down and speeding up. I need this one to be positive and this one to be negative. So let's go back and look at our sign charts. I need a section where f double prime is positive. Okay, so I'm going to kind of zone in on this section and this section. And at the same time, f prime has to be negative, which is this section and this section. So how can I describe them? What parts overlap? So I could say from -8 up until what number are they different? Who comes first, -7 or -3? I would say from -8 until -7, okay, f double prime is positive, but f prime is negative. And then I could also say, so if I've got from 4 to 7 and 0 to 6, the part that overlaps would be from 4 to 6. Oops. From 4 to 6. So I'm just looking for the part that overlaps. So in this section, f double prime is positive, but f prime is negative. All right, in part D, they want us to sketch what f might look like, a possible sketch of f. Now, the one thing that we need from the directions here, so why don't you, pause a minute, get this nicely sketched out in your notebook. The one thing they do tell us is one coordinate of f. There is one thing we know, that f of 0 is 5. So when x equals 0, we know our y value is 5. Okay, that's basically the only point that I know. So let's use our sign chart to try to figure out what's happening. So remember, this first sign chart gives away the shape. This function, and I'm just going to connect my arrows, went decreasing, increasing, decreasing, and increasing. So I know my picture of f has to look something like this. Now the only thing I have to be careful about is my concavity in points of inflection. So from -8 to -7, okay, my function should be decreasing. Now I don't know if I'm up here, if I'm down here. I only know I have to go through this point. Alright, so this is just going to be a rough sketch. That's the only point I know I have to hit. So we could have different versions of this. But I know from -8 to -7, I'm decreasing, and at the same time, concave up. So let's just make it look like it's concave up. When I get to -3, I have a point of inflection. So I'm decreasing until I get to -7. Then I have to start to increase. Whoops, pretend those connect. So I'm going to increase all the way until I get to 0. Okay, then I'm going to decrease till I get to 6. And then I'm going to increase Now, that took care of this chart. I have to go back and check my concavity now. Am I concave up until I get to -3? Alright, so right till I get to -3, this needs to look concave up. So you might have to go back and tweak it now. So I just want to make sure that looks very concave up. This should be a point of inflection, and now I should be concave down all the way till 4. So right when I get to 4, I need to make this look very concave down. So I might just, tweak it a little, make it a little more concave downish. Then from 4 to 7, I need to be concave up. So that's a point of inflection. It should now go concave up. And that's all. Alright, and this is just one variation. This is a possible graph of f. So like I said, you certainly could have had yours way down here, come up and hit that, come way down. There's lots of different variations. This was the only point I had to go through. Alright, example 2. Let g be a function defined on the closed interval from -8 to 9, and g of 2 equals -1. The graph of g prime, the derivative of g, consists of 2 semicircles and 4 line segments, as shown below. So let's slow down and be very, very clear, nice and big, that this is g prime. Okay, and that's huge, that you have to know who you're looking at. Now notice, g of 2 equals -1 will not be on this graph, because this is a graph of g prime. That'll be on the actual g graph. Alright, so I'm going to slow down and make myself 2 sign charts. G prime describing g, and let's be clear that this goes from -8 until 9. Okay, so the first thing I always say to myself is, when does g prime equal 0? That's how I make a sign chart. When does g prime equal 0? This happens to be a graph of g prime, so I'm literally looking to see when it hits 0. I would say it hits 0 at -4, at 0, and 5, and 9. So those are my critical points. Oops, I might have said -4, but that's -6. -6, 0, 5, and 9. Okay, now I'm literally looking to see the values of g prime. Okay, it says g prime, so I'm looking at g prime. And between -8 and -6, I'm above the x-axis, so g prime is positive, which tells me g is increasing. Between -6 and 0, I'm above the x-axis, so g is increasing. Between 0 and 3, I'm below the x-axis, so g is decreasing. And from 5 to 9, g prime's above, therefore g is increasing. Okay, now let's go do the same thing for g double prime. Now I'm going to warn you, g double prime is extremely ugly. Okay, look how many different slopes we have. Alright, I'm going to make that pretty long, and hopefully I can squeeze everybody in there. So I'm g double prime describing g. Now again, here's what I'm saying to myself. I want g double prime, I have g prime. To get from g prime to g double prime, I need to take the derivative. Okay, I'm now saying derivative, and of course derivative means literally look at the slopes. Okay, so there's a lot of different slopes, so let's slow down and talk them through. These slopes are negative. If you can't tell, put a tangent line on it, picture walking down it, it's going down. These slopes are negative until I get to -6. Okay, so I'm negative until I get to -6. Now what is my slope at -6? Do you see that sharp point? Let's be very clear that that derivative does not exist there. Then if I make little tangent lines, my slopes are all positive until I get to the top of the hill here, which is -3, and I want to be clear that my slope is 0 there. Then if I put tangent lines on there, my slopes are negative until I get to 0, because what is the slope at 0? Okay, the slope does not exist. So I want to again be very clear, at 0, the slope does not exist. It has to be a critical point because it's when the derivative equals 0 or does not exist. Then my slopes continue on being negative until I get to 2, where again, my slope does not exist. Now here's a weird little group. Everybody in here has a what type of slope? I would say all those have 0 slopes. I'm literally going to put a bunch of zeros in because that's kind of weird. They all have 0 slopes until I get to 4. And what is the slope at 4? Okay, it does not exist. Then I have positive slopes until I get to 5. And again, at 5, the slope does not exist. That's why I'm stopping there. Then they continue on being positive until I get to 7. And I'm stopping at 7 because I have a slope of 0. then the slopes are negative up until 9. So look at how many different slopes I had. So I want to be clear, on G prime, I was just looking to see whether I was above or below, because this is G prime. In G double prime, I literally had to take all these different slopes. And I had to stop. I understand that this is negative and this is negative, but I had to stop here because the derivative did not exist. Look for those corners and cusps. Now that I have these two sign charts, the math that we do afterwards should be pretty straightforward because we're just going to look at our sign charts. So let's take example A. A says, from negative 8 to 9, find all the values at which G, let's highlight G, has a relative max. So here's what calculus is saying. When I see the word max, min, increasing, decreasing, I am saying take the derivative. Now who do they tell you to do it of? Well, it says the derivative of G. The max of G means the derivative of G. So I strictly go to G prime, okay, derivative of G, and I'm looking for a max. So if I go increasing and then increasing some more, that's not a max or a min. But if I go from increasing to decreasing, look at my arrows there, that creates a max at 0. If I go from decreasing to increasing, that creates a min at 5. So I would say x equals 0 is a relative max. And my justification hopefully is pretty straightforward. F prime changes from positive to negative. Question B. For negative 8 to 9, find all values of G, so let's highlight G, where G has an inflection point. Okay, anytime I see point of inflection, I know I need the second derivative. Now, who do I want it of? G. So I am looking at G double prime. And I'm going to start with my justification. I know I have a point of inflection when G double prime changes signs. Okay, so that's all I'm looking for. I'm going to go to G double prime. Now that was that huge sign chart. And every time G double prime changed signs, I have a point of inflection. So let's start at negative 6. Did G double prime change signs? Yes. So I've got x equals negative 6. Okay, let's look for another time. I went from positive to negative. So x equals negative 3. If I went from negative to negative, I did not change signs. Negative to 0 is nothing. I literally need to see a negative to a positive or a positive to a negative. 0 to positive is nothing. Positive to positive is nothing. But positive to negative is something. So I also have a point of inflection at x equals 7. Part C says find all intervals on the graph where G is increasing and concave down. So let's start with the first word. Increasing means f prime is greater than 0. Okay, if you picture a sign chart, you're increasing when you have a positive value here. So f prime has to be positive, greater than 0. Concave down talks about the second derivative, so f double prime has to be less than 0. So I need to compare these two sign charts. I need f prime to be positive and f double prime to be negative. All right. So my first section, if I look at f prime being positive, that would be in this section. Okay, I'm positive between negative 8 and 6. Now if I go look at G double prime, I want that to be negative. Oops, I'm sorry, these should be G's. G double prime should be negative. So if I look in that section, I would say from negative 8 to negative 6, I can clearly see between there G prime is positive and G double prime is negative. Okay, so let's find another section. Between negative 6 to 0, G prime is positive, and from negative 6 to negative 3, G double prime is positive. I need it to be negative, so I would say in this section, from negative 3 to 0, they overlap. From negative 3 to 0 is in here, where G prime is positive, and G double prime is negative. My last section that I'm positive is between 5 to 9. And if I look at the 5 to 9 section here, I would say over the interval from 5 to 7. Okay, and my justification again is G prime is greater than 0, and G double prime is less than 0. So it's similar to that speeding up and slowing down when we compare velocity and acceleration. And hopefully you caught that mistake I made, and let me go back and fix that there. I wanted G double prime to be less than 0, which is negative, so it would not be that section. I would say from 7 to 9. Sorry about that. Alright, so now my goal is to graph this function. And remember, the only point I know for sure is the point 2, -1. The rest of the points I'm just assuming, so our graphs may look, kind of stretched or shrunk of each other, but that's the only point I know for sure. So we just go through and make sure notice I'm going to increase from -8 to 0, my graph has to be going up. The only thing I have to watch is the points of inflection and the concavity. So from -8 to -6, I'm concave down. So I'd say I'm concave down. And then I have a point of inflection at -6, and I become concave up to -3. Okay. From -3 to 0, I'm still increasing and concave down. So I would say something like that. Okay, now again, this could be stretched more. I have no idea where it is, but I know the shape of it. From 0 to 5, I have to be decreasing all the way to 5. And again, just watch the concavity. From 0 to 2, I'm concave down. Okay. From 2 to 4, notice you are linear from 2 to 4. You can't be concave up or concave down. That means you are a linear function, and I know I'm decreasing because I had a negative slope. From 4 to 5, I'm still decreasing, but I'm concave up. Okay, so that's my 4 to 5 section. From 5 to 9, I'm increasing. From 5 to 7, I'm concave up. And from 7 to 9, still increasing, but concave down. So let's just make sure we have a few things that are true. We should have a max at 0, and that's true because f prime changed from positive to negative. We should have a min at 5 because f prime changed from negative to positive, which again is true. And I would say then this is a sketch of a possible graph of G. Well, we'll have a lot of practice tomorrow, and we'll see you then. Have a great night.